Welcome to aminacademy.com. In discrete mathematics, let us discuss about relations. You can familiar with many relations such as less than, is parallel to, is subset of, and so on. These are some relations between two things. In a certain sense, these relations consider the existence or non-existence of a certain connection between pairs of objects taken in definite order. A ordered pair of an element A and B, where A is designated as the first element and B is the second element, which is denoted by bracket A comma B. In particular, we can say A comma B is equal to C comma D if and only if A is equal to C and B equal to D. Now we'll talk about the relations. A relation can be represented using a directed graph. The number of vertices in the graph is equal to the number of elements in the set from which the relation has been defined. For each ordered pair x comma y in the relation R, there will be a directed edge from the vertex x to vertex y. Now, in relation, there are many types are there. Some types we can discuss here. Concepts are one of the important topics of set theory. Sets, relations, and functions, all three are interlinked topics. The relations define the connection between the two given sets. Also, there are types of relations starting the connections between the sets. Hence, here we will learn about the relations and their types of relations. Relations, simple definition. A relation in mathematics defines the relationship between two different sets of information. If two sets are considered, the relation between them will be established if there is a connection between the elements of two or more non-empty sets. For example, in the morning assembly at school, students are supposed to stand in a queue in ascending order of the heights of all the students. This defines an ordered relation between the students and their heights. Therefore, we can see that a set of ordered pairs is defined as a relation. That means set of ordered pairs in a set is called a relation. Here, look at this. Suppose ordered relations, we can say here one, two, 1, 2, 5, 7 is related to C, A, C, N and A. So here, suppose 1 is related to C, 2 is related to N and 5 is related to A and 7 is related to N. From this relation, we can draw like also. Set and relations. Set and relations are interconnected with each other. The relations define the relations between two given sets. If there are two sets available, then to check if there is any connection between the two sets, we use relations. For example, an empty relation denotes none of the elements in the two sets is same. If there is no elements in a set, it's called a null set, and relation between the two null set is same null relation. Let us discuss the other two types of relationships in mathematics. In math, the relation is the relationship between two or more set of values. Suppose x and y are two sets of ordered pair and x has relation with y, then the values of set x are called domain, the first value domain, and whereas the values of set y are called range. Here, suppose ordered pairs 1, 2, minus 3, 4, 5, 6 like it's given. The domains are first elements 1, first numbers in these elements in every sets, that is 1, minus 3, 5, minus 7, 9. These are domain. Its range is 2, 4, 6, 8, 2. 2, 4, 6, 2, 4, 6, 8. This is the range. Now types of relations, there are more types of relations, that is empty relation, universal relation, identity relation, inverse relation, reflexive, symmetric, transitive, equivalence. What is empty relation? An empty relation or void relation is one in which there is no relation between any elements of set. For example, here the set A is considered as 1, 2, 3. Then one of the void relations can be R equal to xy, where x comma y is 8, the empty relation, because here that suppose here x comma x minus y modulus x comma y is suppose 8, the empty relation we can write for any number here. Empty relation is R is equal to empty set is subset of A cross A. The universal relation. The universal relation is or full relation is a type of relation in which every element of a set is related to each other. Consider set A equal to ABC. Now one of the universal relations will be R is equal x comma y, where minus x minus y modulus is greater or equal to 0 or for universal set. That means on each and everything is related. That means relation is equal to A cross A. Now identity relation. An identity relation, every element of a set is related to itself only. For example, set A is A, B, C. The identity relation is A to A, B to B, C to C. That is itself, it's related. You can define this identity relation as I is equal A comma A, and A is element of set A. Inverse relation. The inverse relation is seen when a set has elements which are inverse pairs of another set. For example, set A have A, B, C and D. The inverse relation is R inverse is equal to its inverted BA and DC. Therefore, R inverse is equal to B comma A is ratio to such that A comma B is element of R. Reflexive relation. In a reflexive relation, every element maps to itself. For example, consider a set A is 1 comma 2. Now an example reflexive relation is 1 is related to 1, 2 is related to 1 is related to 2, 2 is related to 1. Reflexive, that means 1 is related to itself and 2 is related to itself and 1 is related to and 2 is related to 1. All together is considered reflexive relation. So A comma A is an element of R. Symmetric relation. In a symmetric relation, if A equal to B is true, then B is equal to A also true. In other words, a relation R is symmetric only if B comma A is related to R is true when A comma B is related to R. Even the letters are interchanged, it is related to R. So it's called symmetric relation. An example of symmetric relation will be, look at here, relation 1 to 2, 2 to 1 for a set of 1 comma 2. That is 1 is related to and 2 is related to 1. here, which is equal A related to B and B related to A, where A comma B is element of A, is a definition for symmetric relation. Transitive relation. For transitive relation, if x comma y is element of R and y comma z is related to R, then we can say x is related to z is called a transitive. That is, or if one first set is x comma y is related to R, element of R, y comma z related to element of R, then we can say the first element with the last here. That is, R, x is related to z, which is element of R, then we can say it's a transitive relation. For a definition, A related to B and B related to C, which is equal A related to C. And A comma B comma C is an element of A. Equivalence relation. If a relation is reflexive, symmetric and transitive at the same time, it's known as an equivalence relation. Equivalence relation is together with reflexive, symmetric and transitive. These are table form what we discussed above. Now we'll discuss further about in mathematics the product set. The Cartesian product of set A and B is defined as the set of all ordered pairs, that is x comma y, such that x belongs to A and y belongs to B. For example, set A is 1 and 2, set B is 3, 4, 5. Then the Cartesian product of A and B is here, 1 is related to 3, 1 is related to 4, 1 is related to 5. Then 2 is related to 3, 2 is related to 4 and 2 is related to 5. These are the Cartesian product of A and B is set of this. Now the product is defined as A cross B. Product relation is equal, the definition is A B such that A is element of A and B is element of B. The definition. Now if we can say A square if A is related to A itself. A related to A, which is called A square. Now for example, if A equal 1, 1 and 2 and B equal A, B, C, then you know that A cross B is 1A, 1B, 1C, 2A, 2B, 2C. Similarly, you can say B cross A is just inverted. A comma 1, B comma 1, C comma 1, 2 comma A, A comma 2, B comma 2 and C comma 2. Here, these are some relations we talked about. Suppose when symbolic form. Suppose if A comma B is element of R, when we say A is, if A is related to B, B is written as A or B. If not related, then A is not related to B. Like that we can write in symbolic form. For further details, we'll discuss in later videos. We have done. Please subscribe our YouTube channel.